Question 18 of our test 7 on compound angle formulas. Question is solve square root 2 sine theta equals to square root 3 minus cos theta, where theta is between 0 and 2 pi. Now, to find theta, we can square both sides and then solve, correct? So let's do that part. So we have this, so when we square both sides, we get 2 sine square theta equals to, here let me expand it, square root 3 minus cos theta whole square, correct? So when we squared the left side, so square root 2 became 2 and then sine square theta, and here we have square root 3 minus cos theta whole square. So let's expand this. So when you expand this using a minus b whole square, we get a square minus 2ab plus b square. So a square is 3 minus 2 times square root 3 cos theta plus cos square theta. So that's what we get. Now if we write sine square theta in terms of cos square theta, that is 1 minus cos square theta, then we get a quadratic equation in cos, right? So then it would be easy to solve. So let's do that part. So the left side is 1 minus cos square theta, and the right side for us is 3 minus 2 square root 3 cos theta plus cos square theta, correct? So which is 2 minus 2 cos square theta equals to 3 minus 2 square root 3 cos theta plus cos square theta, correct? Now let's bring all the terms together to one side and then solve for cos theta. So let's say 0 equals to, we'll bring this here, so 2 cos square theta plus 1 will become 3 cos square theta, and we have here 2 square root 3 cos theta, 2 square root 3 cos theta, and that is 3 minus 2 as 1 plus 1, correct? Now this can be factored. So think like this. This is square root 3 cos theta whole square, and this is 1 square, and this is 2 times AB. So you can write this as square root 3 cos theta minus 1 whole square. So that is how this can be factored, correct? Equals to 0. Now the solution for this will be that cos theta equals to 1 over square root 3. So this will be 0. That means cos theta equals to 1 over square root 3. So that will give us a solution for this particular equation. Now within the domain of 0 to 2 pi, cos theta will be positive in quadrants 1 and 4, right? It is positive in quadrants 1 and 4, correct? So, using the cost rule. So we'll follow these simple steps most of the time to get all our answers. So the simple step here is always find acute angles. So we'll find the acute angle, let's say alpha first, right? And then worry about all possible answers. In this particular case, we know the acute angle is also our solution, and the other one is this, correct? So we can always write plus minus alpha. It is going to the other side. Well, we cannot write minus alpha since we need to give 0 to 2 pi. So we should give answers in this form, correct? So one solution for us is alpha, and the other one is 2 pi minus alpha, correct? So let's use a calculator and then figure out what the related acute angle is. So cos theta is 1 over square root 3. So we'll say cos inverse of 1 divided by square root 3 is equal to 0.9553. It is, so we get from here, let me just do it on this side. Okay. So we get theta equals to cos inverse of 1 over square root 3, and we get one of the solutions as 0.9553, 0.9553. 0.95553. So that is one of the solutions, right? The other solution will be 2 pi minus theta, right? So we can do 2 pi minus theta minus 2 pi equals to 5.2327. So the other one is, so the other answer is 2 pi minus 0.9553, and that is 5.3278, correct? So we can write down our answers as, within this domain of 0 to 2 pi, that angle theta is equals to, you can round this to 2 decimal places, for example, and then write 0.96 and 5.34, correct? And let me just make a correction here, kind of. I actually found the angle alpha first, right? So we should always write alpha equals to cos inverse. Always find the related acute angle, right? 1 over square root 3, and that was 0.9553, right? And then we figured out that cos is positive. So that means we are looking into these two quadrants, and one of the angle is alpha itself, and the other angle is 2 pi minus alpha, and that is how we got our solution. Okay, so that is the solution for the given equation. Thank you.